In our last video, we covered dictionaries, which map keys to values. In this video, we're going to cover sets, which kind of behave like lists that don't allow duplicate items. But you can also think of sets as dictionaries where we're just keeping a collection of keys and we don't really care about the value type. So let's take a look at that together. Let's see how this set data structure works in Elm. So like I was saying with the lists, if I have a list of numbers, I'm just going to call it list to be extra vague. I could have a list that has these repeats. So if I think I just opened a new terminal. If I do this, oh, you know what? I deleted something. I deleted a value and I think it just got tripped up. All right, take a look. So I've got a list of numbers. It's got two 2s in it. All right, let's say I want to make it so that I'm not duplicating any of the numbers in my list. What I can do is I can use a set instead of a list, and that'll guarantee that for a given value, there's only going to be one copy of it in that list. So if I do import set, exposing set, now I'll be able to use the set module, and I'll be able to use the set type without needing to use the set dot prefix everywhere. So let's do set dot from list, 1, 2, 2, 3, and you'll notice that it got rid of that duplicate. Another thing to keep in mind is that sets don't retain order. So notice that I put the 3 in the front, but it didn't do 3, 1, 2 and drop the last 2. The order of a set is not reliable. So sets are really just, you can think of them as like a little, really they are just dictionaries where you are able to insert 3, insert 1, insert 2. And then when you go to insert 2 again, it's already there. So I'm not sure if under the hood, if it just inserts it on top of the other one or if it just ignores it. But I think the performance is good enough that I don't need to worry about it. So that's kind of how that's what sets are for at a high level. You can also use sets to check to see if there's an item in your list. So, or if there's like a certain value. So I'm going to say numbers is going to be, my set. So I can say set.member is that a member of my numbers set. And this is a lot faster than using a list, because with a list, there's really no like ergonomic way to check to see like, hey, is this in there? You can say list.any, x equal 5 from my numbers, from like 1, 2, 2, 3, but this is a little bit more cumbersome, and it's going to loop through the whole list until it finds the entry. With a set, it's just a direct lookup, so it's going to be a lot quicker for you. And that's why you see the member function is available in the core library for set, whereas it's not available for list. That's not what lists are for. So set member is really fast. The only thing that I wanted to mention with dictionaries and sets, I forgot to cover this in the last video, is that sets require the values that you use for them to be sortable. So what I mean by that is, at least in Elm 19, if you make your own custom color type, you cannot make a set of colors. So it's kind of ambiguous, the ordering of these things. So the Elm doesn't allow you to make sets of like custom values. So set.fromList. So you'll see here that it's talking about this comparable, this lowercase thing. This is a constraint that's kind of built into the Elm compiler. So while you can use a set to make ints, you can use a set to keep track of bools, keep track of strings, or keep tracks of like, even tuples, which have an order to them that's defined. You can't use sets or dictionaries to store non-comparable values. So that's kind of like a little gotcha that I wanted to mention. But yeah, sets are great because what you can do is you can use functions like union or intersect to see if two lists contain the same value, that kind of thing. So if you do set.union of 1, 2, and 3, and set of 3, 4, and 5, it's going to return you a new set where it combines all those together. And you can even use functions like intersect to tell you, hey, for these two lists, where is there any overlap, if there is any overlap. So you can say, hey, 1, 2, 3, 3, 4, and 5, they share kind of like a little Venn diagram. That 3 is that common number. So sets are really great for working with data types and trying to figure out like, hey, do I have this value? Have I found this value so far? Or comparing two sets, how many values are here? How many values are there? Is there any overlap? Sets are really great for that. So I use it for those kinds of use cases. That's pretty much it. There's not too much more to talk about sets. For all these data types, all these data structures, I'm just going to open up Safari real quick and show you where you can go for more information. Packageelmlang.org. This is the Elm package site. We're going to cover this in an upcoming video in more depth. But all these data types, all the docs for this, if you go to package.elm-lang.org, you can click through this and you can not only see what arrays are, get a reminder of like, what you kind of want to use them for, but you can see all the different functions, all the types. And that's not just for arrays, that's for dictionaries, that's for characters. When you're working with numbers, you're trying to remember, int, float, all that stuff. Everything I've covered so far, you can check that out. And there's going to be, links in the description for this video to help you get to this URL in one click. But this is something I reference all the time, and I've been doing Elm for like 8 years at this point. So, it's definitely valuable, definitely worth checking out. That's it. All right. See you guys in the next video.